So welcome to Fabian Electrical Services Inc. And tonight we're diving deep into three critical areas of Canadian work: breaker sizing, load calculation, and sub-panel wiring. If you're working in residential, light commercial, or prepping for inspection, this stream is for you. We're using the OESC 2024 as our reference point, so have your code book ready and take notes. Let's get right into it. Again, East Badness. Again, thank you for checking into the live stream. Also, thank you for the continuing support towards the channel. So again, for all those who are checking in to the live stream or who's watching this, don't forget to like up the live. Helps with the algorithm. So I'm going to be running a video first of all, and then I'm going to go into the actual 2024 Ontario Electrical Code Book. To actually pull up the latest code rules that's in the book. So I'm going to try to stay away from streaming the videos tonight. I am going to pull up the code book by streaming it, but let's see what happens. So I'm going to run one video, and then I'm going to pull up the code book and get more in depth into it. So again, this is a panel, 100 amp panel installation, and this is actually a panel change out. And when it comes to sizing your wires, you have to size your wires to code. Up Movement TV, again, also thank you for checking into the live stream, and also thank you for the continuing support towards the channel. So what this is simply a panel swap out. So now when it comes to a panel swap out, it's simply I'm changing one older panel I'm going to be removing, which is this panel. I'm going to reinstall a new panel. So when it comes to removing the panel and sizing your wire for the main, we normally go into the code book and we size our wires accordingly for the 100 amps. I think for the 100 amps, it's I want to say number 2 wire. And again, how we get this sizing, we go into the back of the code book, and we simply there's a rule there with the number, with the amps that you're going to be using and what is amps. Amps is simply a calculation that we do to figure out how many amps that we actually have coming into the home. Um, where do those calculations come from? They come from your sizing of your electrical outlets. It comes from your sizing of your washing machine, which is a lot of times the same size. I think there are some difference. The newer ones, I believe, they come linked together, and you either need most of the time you need a 30 amp, I believe, or a 15 amp. I believe it's a 30 amp. So that is the stackable ones. So we get our power from there. We get our amps from there. That's what it's called. Uh, what else you have? You have your actual water tank, for instance. Your water tank, it might say on there a couple lamps. That's where we get our actual load for the actual circuit. And then what we do is we're going to tally up those all up and see what number we come out with. And we're going to size that panel according to the 80% rule, I believe it is 80% rule. Hope I'm not wrong, but I believe it's the 80% rule that we're going to size it for, which will give the panel enough room for the wires to work. You don't want to oversize. You don't want to cram your panel up with too many circuits, and you undersize your actual conductor. It's going to be working a lot harder than it's supposed to be. And a lot of times that's where you have a lot of the issues coming in. So and then you have the wire size, which is the number 12, number 14, number 10, number 8. Those are the wires that we use in the homes. Commercial also, all depends. So I'm going to, like I said, run this video here, and then I'm going to pull up a rule. So again, I'd like to thank all you guys who tuned in to the live stream. Again, don't forget to hit that like button. Hit up the like button as you come in. Helps with the algorithm. So again, this rule here, I'm going to pull up this rule here where you're going to see the actual. A lot of times I explain and I will say the phasing of the tape. Um, so I'm going to pull that rule up first of all, and then I'm going to pull up another rule here where you will see inside of the code book. So phasing, that's what we do when we're phasing. We normally phase with the white tape, neutral. That's the color tape that you're going to need. It is a white, it's called an unidentified conductor. So that's what we're going to use, the white tape. Again, for the grounding, when it comes to the grounding and bonding, it's normally a green conductor. So we simply tape it green. And when it comes to your phasing, red, black, blue, those are the tapes that we're going to be using when you want to phase your sorry about that. So yes, so those are the rules that are all inside of the code. So I'm going to So I'm going to kill this video here. Sorry, I'm going to stop this video here, or maybe I'll let it run. So what this is a 400 amp installation. Wires are sized to the actual 400 amp panel. Again, the rules comes out of the code book with the actual load calculation that you're going to do for the home. Okay, so I'm going to share my screen here. Okay, so I'm going to have to come out of there, share that. Okay, so I'm going to start here and we'll work our way back. So again, this is switches. This is operational of switches. This is another code rule inside of the Ontario Electrical Safety Code, OESC, that I'm going to be referencing to. And again, breaker sizing according to the Canadian Electrical Code. This is then you have the load calculation for the residential panel. So I'm going to read this first. So it says nice switches and other control devices unless located or guarded in a way that redeem them inaccessible to authorities, to unauthorized persons, shall be constructed so that they can be switched to the off position without exposing live parts. So what that is there are different type of switches, um, and those switches, they do have, I believe, the live parts, and it has to be constructed in a way where no one is going to be obviously hurt. So so there you see it here. It says shall be constructed so that they can be switched to the off position without exposing live parts. Mounting of nice switches, singletron switches shall be mounted with the bases in a vertical plane. Singletron knife switches shall be mounted so that gravity will not tend to close them. Double thrones knife switches shall be permitted to be mounted so that the throw will be either vertical or horizontal. But if the throw is vertical, a positive locking device or stop shall be provided to ensure that the blades remain in the open position when so set. unless the switch is not intended to be left in the open position. So these are again special switches that you use. These are not the your regular switches that you're going to be seeing inside of the home. Then it says maximum rating of switches, unless of special design, nice switches rated at more than 600 amps at 750 volts or less shall be used only as isolating switches. These are the disconnect switches that they're talking about, depending on the load. Connection of switches, manual single thrown switches, circuit breakers, or magnetic switches shall be connected so that the blades or moving contacts will be dead when the device is in the open position, except that the following need not comply. So again, manual single thrown switches, circuit breakers, or magnetic switches shall be connected so that the blades or moving contacts will be dead when the device is in the open position, except that the following need not comply. It goes on to say branch circuits that have all live parts other than terminal seal and that are constructed so that the line and load connection can be interchanged. Switchgear that is provided for sectional purposes and has a suitable caution notice attached to the assembly. So the switchgear is normally you normally find that on commercial inside of the main electrical room. That's what we call it, a switchgear. Switches that are immense in a liquid and have a suitable caution notice attached to the outside or the enclosure. Switches that are designed so that all live parts are inaccessible when the device is in the open position. Magnetic switches, when preceded by a circuit breaker or manual switch that is located in the same enclosure or immediately adjacent and is marked to indicate that it controls the circuit to the magnetic switch unless this is obvious. So then it goes on to tell you the rating of general AC, DC switches, and if you ever happen to be using your code book and you do see the appendix B, after you have read this entire section, you just need to head over to Appendix B, where you're going to gather up a lot more information that you will need when it comes to the installation. Sorry about that. Here, I'm just looking for. Okay, so I'm going to read this here. For non-inductive loads after other than tungsten filament lamps, those lamps switches shall have an ampere rating not less than the ampere rating of the load. So ampere rating not less than the ampere rating of the load simply means that I cannot install a 20 amp switch for a 15 amp circuit that's going to be happening. For tungsten filament lamp loads and for combined tungsten filament and non-inductive loads, switches shall be T-rated except where the switches are used in the branch circuit wiring system in dwelling units, in private hospitals or hotels rooms, or in the similar location, but not in public rooms or places of assembly. The switches controls permanently connected to luminaires or lighting outlets is one in one room only or in one continuous hallway where luminaires may be may be located at different levels are in purposes, and the switch is rated at not less than 10 amps, 125 volts, 5 amps, 250 volts, or for the four-way types, which you're going to see me using instead of the home where I'm working. It says 5 amps, 120 volts. Notice everything here is 125 volts. This is actually the lower single line that you're going to be using. So that means it's going to be one hot going in with a neutral, um, or you have 250 volts. Canopy switches controlling the tungsten filament lamp load shall be T rated or shall have an ampere rating at least 3 times the ampere rating of the load. So that's a little bit about the switches. I'm going to try to get over to where I actually. So again, this is the I'm working off of the Ontario Electrical Code Book. Shorter version is the OESC Code Book, and we're going to be getting into the topics tonight, which is going to be breaker sizing according to the Canadian Electrical Code, a little bit of load calculations for residential panels, sub panel wiring in Canada, how we go about doing that. So these are a couple topics that I want to pull up the info. So I'm going to continue going back my way here, where I want to. So I'm trying to get to a specific rule. That's why you see I'm heading back um, towards the front of the code book. I'm actually trying to land on the actual rule with the the identify. Okay, so here we go. Here, let's see if this is the identification. Okay, let's go one step back here and see what this have here. Okay, so let's go all the way back. So again, this is section 4000 of the code book, Ontario Electrical Code Book, OESC code book that I'm going to be using. And installation of neutral conductors. This is a rule that maybe a lot of people will probably want to know. Except as permitted by Rule 6-302 to 6-308. Then it tells you another rule 12-302 and 12-318. Neutral conductors shall be insulated. So again, these rules, it says except as permitted by rules. You simply head over to these rules here and see what it is going to give you, and that's normally how you go about using the code book. So where insulated neutrals are used, the insulation on the neutral conductor shall have a temperature rating not less than the temperature rating of the insulation on the underground conductor. Size of neutral conductor, it will also send you to Appendix B, but it will take me a long time to get to Appendix B, so I'm going to stay away from Appendix B, and one day I will actually go into the Appendix B. The neutral conductor shall have sufficient ampacity to carry the unbalanced load. So it just goes on to tell you here, The neutral conductor shall have sufficient ampacity to carry the unbalanced load. The maximum unbalanced load shall be the maximum connected load between the neutral and any one underground conductor as determined by Section 8, but subject to the following. There shall be no reduction in the size of the neutral for that portion of the load that consists of electric discharge lighting or nonlinear load supply from a three-phase four-wire system, and except as required otherwise by item A, demand factor of 70% shall be permitted to be applied to the portion of the unbalanced load in excess of 200 amps, and the unbalanced load is simply the neutral that we're talking about. The size of a service neutral shall be not smaller than the size of a neutral selected in accordance with some rule 1. That what that there is saying, your main size wire coming into your home shall not be smaller than the wires that you actually have going out to the home. So let's read this again. The size of a service neutral shall be not smaller than the size of a neutral selected in accordance with sub-rule 1, and shall be not smaller than number 10 copper or number 8 aluminum. So I'm going to send this forward. Again, I'd like to thank you guys all for tuning in to Fabian Electrical Services Inc. And also, again, I have some videos that are pinned in the comment section. There are links to my previous live streams with grounding and bonding. Also, you have the AC disconnect live stream also there. So these are the last couple of live streams that I've done. Common, and then it says, besides not smaller than a grounded conductor as required by Rule 10-210, except in service entrance cable, or whether the service conductor are number 10 copper or number 8 aluminum, and determine the ampacity of an uninsulated neutral conductor run in a raceway. It shall be considered to be insulated with insulation having a temperature rating not higher than that of the adjacent circuit conductor. So again, also I'd like to thank East Badness for checking into the live stream, and also I'd like to thank Up Movement TV for checking in to the live stream. So again, for all those who are checking into the live stream, we're going over a couple stuff here. Right now, I'm in the Ontario Electrical Safety Code Book, and I'm in the section 4, where it deals with the neutral conductors. We're going to possibly get into breaker sizing according to the Canadian Electrical Code, and some load calculation for residential panel. So it says here, common neutral conductor, provided that when in metal enclosure, all conductors are feeder circuits employing a common neutral are contained within the same enclosure. So it simply says, provided that when in metal enclosure, all conductors are feeder circuits employing a common neutral are contained within the same enclosure, a common neutral shall be permitted to be employed for 2 or 3 sets of 3-wire single-phase feeders, or 2 sets of 4-wire 3-phase feeders. Basically saying that, sorry, let's read this again. Provided that when in metal enclosure, all conductors or feeder circuits employing a common neutral are contained within the same enclosure, meaning that you simply have to run your conductors all in the same pipe. I believe the ground wire is different. If it's not a actual if it's you're doing a sub panel, the ground wire can be ran in a separate pipe. But there is a rule for that, and if we do come across it, I will read it out. It's something that I've done before. I know there's a rule for it. Um, Identification of insulated neutral conductors up to and including number 2, AWG copper or aluminum, except as permitted in sub-rule 2 to 3 and 4. All insulated neutral conductors up to and including number 2 are copper or aluminum, and the conductor of flexible cores that are permanently connected to such neutral conductors shall be identified by a white covering or by 3 continuous white stripes along the entire length of the conductor. So that is where you would see my previous video that I just ran. Again, I played that for a reason. They have the you can see me using my white tape to identify the neutral conductor when it is not identified. So I'm going to read that rule again. Except as permitted in sub-rule 2, 3, and 4. Um, it says all insulated neutral conductors up to and including number 2, uh, 2 copper or aluminum, and the conductors of flexible cores that are permanently connected to such neutral conductors shall be identified by a white covering or by 3 continuous white strips along the entire length of the conductor. And that's how we basically identify our neutral conductor. In the previous video, like I said, you're going to see it there. I am identifying my conductor with white tape. That's where the rule comes from, right here. So again, we are going to also. Um, so again, I'd like to thank all those who have checked into today's live stream. Again, as you guys come in, don't forget to like up the live stream. It's free. Again, today's live stream, we're going to be getting into some breaker sizing according to the Canadian Electrical Code. Um, some load calculations for a residential panel, which I would have already been through that already. Sub panel wiring in Canada, neutral and ground separation in sub panel, how to size breakers based on ampacity. So I believe also I would have went over that at the beginning of the live stream, but I'm actually going to see if I can pull it up. And now we're into the identification of insulated neutral conductors up to and including number 2, copper or aluminum. What this simply means up to. You cannot go below that to sorry, up to and including. So up to, I believe the smallest I can identify white is a number 6, if I'm not mistaken. I might be wrong, but I think it's something like that. Except as permitted in sub rule. So 2 and 3 and 4, you simply go to this sub rule here. Where conductors of different systems are installed in the same raceway box or other types of enclosure, and the identified circuit conductor of one system is colored by a white covering, each identified circuit conductor of the other system, if present, shall be provided with a specific identification, and the identification shall be permitted to be an outer covering of white with an identification. identifiable color stripe, I guess, not green, running along the insulation. Rare conductors of different. I'm going to read that over again. I'm kind of having problems seeing the. I wish maybe I should. Oh, you know what? Okay, I'm going to just leave it like that. If I trouble it, I might get kicked out. So of StreamYard. So let's just leave it the way it is. So it goes. Rear conductors of different systems are installed in the same raceway, box, or other types of enclosure, and the identified circuit conductor of one system is colored. Is covered by a white covering. Each identified circuit conductor of the other system, if present, shall be provided with a specific identification. That means you're going to change up your you're going to change up your your tape that you're going to use in different colors. You're not going to make them all the same colors. You're going to end up mixing up circuits. The covering of the other conductors or conductors shall show a continuous color contrasting with that of an identified conductor. However, in the case of those flexible cores where the identified conductor is identified by a raised longitudinal ridge. I'm having problems reading that. The other conductors shall have no ridges. First time I've seen that word, so excuse me. For a multi-conductor cable, the insulated neutral conductor shall be permitted to be permanently marked as the identified conductor by painting or other suitable means at every point where the separate conductor have been rendered accessible and visible by removal of the other covering of the cable, and the painting or other suitable means of marking the identified conductor shall not render illegible the manufacturer numbering of the conductor. So I'm going to leave that there. I'm going to pull up another I'm going to pull up another play video. Let's see if I can play this video with the streaming still intact here. Okay, so we're going to run this video here.
So this is just a little patch that I had to remove here. Obviously, this is not going to match back up, so I'm not going to reinstall this. But this one I've reinstalled. So again, thank you guys for tuning in to the video, and please don't forget to like up the video. You can also become a member of the channel, and you can also subscribe to the channel, and I'll catch you guys in the next video.
So in this video, what we have is simply I will be changing out my switches as the switches are defective, and as we all know, with defective switches comes problems. You can even sustain electrical shock from the defective switches. With the face of the switch removed, a lot of times we don't care for these things, but these things can end up hurting.
So these are the photos are just work that I normally do on a daily basis. It can be anywhere from pipe work to pot lights, you name it, I do it. So again, just sit back and enjoy the full video. Hey folks, let's dive into today's video, which is simply going to be the fundamental of troubleshooting an electrical circuit. I will be showing you the steps I take to get this done. Thanks for reaching out to me, Trill. So basically, I will be taking my hot, which is black, and my white, which is neutral, and placing them together. Please do not try this with your power on, as it can become dangerous. Also folks, go ahead and hit that notification button and stay tuned for my other videos on troubleshooting. You can also head to the comment section and stay up to date in my community posts and leave a comment in the comment section telling me if this video was helpful to you or not. Thank you.
So hello again, and welcome back to the channel, and I would like to thank you guys all for tuning in to Fabian Electrical Services. So again, this is just going to be another short live stream, possibly over an hour or so. So if you're just joining, welcome. So far we've covered proper breaking cycle, this unload and conductors.
Hello and welcome back to the channel, and I'd like to thank you guys all for tuning in to today's video. Also, as you come in, please don't forget to like up the video, very important, and you can also share the video. You can also become a member of the channel, and you can also subscribe to the channel. So in today's video, what we have is simply a roughing that was done throughout the home. So this is basically a walkthrough of the finishing, before finishing, before the drywall goes up. As you can see, you'll see all my wires are neatly strapped. When it comes to my wires going through the 2x8, it's dead in the center. There's a code rule on that also. You'll also see I have some speaker wires, pot lights, the whole 9 yards, security wiring for the home. We have some TV outlets, data outlets, 2 game bots. We have the washroom. In here is going to be an office, and as you can see, the receptacles are going to be coming out through the baseboard, and we have here we have 1 floor receptacle. And as we go into the washroom we have fans, 4 pot lights, we have LED mirror, a GFI receptacle, toilet receptacle, we have our switches also by the door. So as I said, this is filled with lots of stuff, the entire home. As we go into this room here, you'll see same thing, my receptacles. There's no box on them because they're going to be coming out of the baseboard. That's where the receptacle is going to be placed. In here you're going to have LED strip lights at the top, so you can see my switches neatly supported on both sides according to the code.
and here also is filled with security wiring. Also, there's going to be a heater here.
So hello again and welcome back to the channel. Again, if you're just joining, welcome. So far we've covered proper breaker sizing based on loads and conductors, and now we're moving into sub panel grounding and bounding. Drop your question in the chat and don't forget to like the stream and hit subscribe if this content is helping you. So basically what we're doing tonight is we're doing a little bit of breaker sizing according to the Canadian Electrical Code. Again, I'm working off of the Ontario Electrical Code book tonight. Not working off of the Canadian Electrical Code. This is the Ontario Canadian Code book, very similar, OESC. Again, we're going to hopefully get into some load calculations for residential panels. Again, when it comes to sub panel wiring in Canada, what we normally go about doing. Hopefully I can pull up the neutral and ground separation in the sub panel. I do have a video that I can play. I don't know if I'm going to risk it because I have to stream it. So I'm trying to avoid streaming the actual videos tonight. How to size breakers based on ampacity. I would have explained that. I'm going to see if I can actually go to the actual rule in the back of the book. If not, it'll be a second episode on this. Maybe I'll turn it into an episode. Maybe I should label it episode 1 code book, probably. We'll see. Let me write that down just in case. Maybe I can do that. And just make it as a continuation topic. So again, neutral and ground separation in sub panels. How to size breakers based on ampacity. OESC 2024 rules update. I do have it here, but I'm probably not going to get to it tonight. Like I said, I'll leave it to another episode. Electrical code, panel code compliance. We want to go over that a little bit. We did speak about that on my previous live stream. Breaker sizing for HVAC or AC units. I did pull that up at the beginning of my live stream tonight. We went over a little bit of the breaker sizing for HVAC or AC units. We didn't touch the CSA approved panels and breakers. Again, that's in the actual video. It is also inside of the code book. I just have to find it. Service upgrade, wiring and code. Maybe we should head to that section, which is going to be section 6. So I'm going to go back to the actual screen that I have up here, and I'm going to go back to to section 6 here, and that's going to bring us to the service entrance. Is what we do. It's a service and service equipment. So again, let's open up the OESC 2024 and look at the rule. And what we're looking at right now is we're going to be looking under the service entrance rule. So basically what this says, transformer rated meter mounting device. A meter mounting device with current transformers and with or without test switches mounted in the same enclosure. Number of supply service permitted. Then it's going to send you to the Appendix B. Two or more supply services of the same voltage shall not be run to any building except the additional supply service shall be permitted by for supplying. Basically tells you fire pumps in accordance with the rule, sends you to that rule, and also is going to tell you head over to sub-rule 1. Industrial establishments and other complex structure or complex self-contained occupancy where the occupancies are not located one above the other and have a separate entrance with direct access to ground level. It also goes on to say when two or more supply services are installed to a building, all service boxes associated with the various consumer service shall be grouped where practicable. Sorry about that. When two or more boxes installed in accordance with sub rule 2 are not grouped together, a permanent diagram shall be posted on or near each service box, indicating the location of all the other service boxes supplying power to the building. So again, when you do see stuff that are being labeled, it's all coming from inside of the code. That's why we do what we do when it comes to the electrical. Number of consumer service permitted in or on a building, the number of consumer services of the same voltage and characteristics terminated at any one supply service run to on or in any building shall not exceed 4 unless there is a deviation allowed in accordance with rule 2-030. Um, Deviation from my knowledge, I think it means if the rule, um, if you can overlook the rule, override the current rule. I believe that's what it means. I might be. Current supply from more than one system when an installation or power of an installation is to be supplied with current from two or more different systems, the switches equipment controlling the various supplies shall be constructed or arranged so that it will be impossible to accidentally switch on power from one source before power from another has been cut off. Supply service from an electric railway system. A supply service shall not be run to a building from an electric railway system using a ground return unless the building is connected with the operation of an electric railway. So I'm going to, that's not the rule that I want to see. So I'm going to shift that over here. Okay, so I have to, so at the bottom here, 6-112, that's the rule. Support for the attachment of overhead supply or consumer service conductors or cables, and that's going to send you to the appendix B. You simply just head over there and you look for the information that is being given. A means of attachment shall be provided for all supply or consumer service conductor. The point of attachment shall be on the same side of the building as the consumer service head or equivalent. Solidly anchored to the structure or service mast. In a position that allows the overhead service conductor or cables to have an angle away from the structure and in compliance with the requirements of the supply authority. The point of attachment of supply or consumer service conductors shall be not less than 4.5 meters, nor more than 9 meters above sidewalk or grade. Exposed service conductors or cables that are not higher than windows, doors, and porches shall have a clearance of not less than 1 meter from the window, doors, or porches. Where service masts are used, they shall be of metal and assembled from components suitable for service mast use, be attached to the building as shown in specification 28, and be guided if required in accordance with your rule 6-118. Rigid steel conduit of a minimum nominal size of 63 trade size shall be permitted to be used for the purpose of Subrule 5, provided that all other requirements for a service mast are complied with. Bolts shall be used for securing the means of attachment at the point of attachment, and if attached to wooden structural members, the latter shall be not less than 38 millimeters in any dimension. The supply consumer service conductor support shall not be attached to the roof of a structure, except as permitted in some Rule 9. Notwithstanding Subrule 8, it shall be permitted to fasten the upper service mast support and the eye bolt to which a guide wire is attached to a main structure member of the roof, such as a roof rafter, a roof truss, or the equivalent. Support for attachment and overhead supply or consumer service conductors or cables. A means of attachment shall be provided for all supply or consumer service conductors. The point of attachment shall be on the same side of the building as the consumer service head or equivalent, solidly anchored to the structure or service mast. So again, I'd like to thank you guys all for tuning in to Fabian Electrical Services Inc. Again, as you guys come in, don't forget to like up the live stream. So let's see where I lost my on the same side overhead service gonna get out away from okay. So let's have an angle away from the structure and the compliance with the requirements of the supplier authority. The point of attachment of supply of the point of attachment of supply consumer service conductors or cable shall not exceed 9 meters above grade or sidewalk and shall be located such that the clearance of supply conductors or cables at any point above finished grade shall be not less than the following: across highway, streets, lanes, and alleys, 5.5 meters; across driveways to residential garage, 4 meters; across driveways to commercial and industrial premises, 5 meters; and across ground normally accessible to pedestrians, only 3.5 meters. Exposed service conductors or cables that are not higher than windows, doors, and porches to have a clearance of not less than 1 meter from the window, doors, and porches. Where service masts are used, they shall be of metal and assembled upon components suitable for service mast use. Rigid steel conduit of a minimum, I believe I read that. Okay, so I'm going to actually get out of that one here. Installation of underground consumer service. So I'm going to run another video here, and then I'm going to come back. So again, for all those who are checking in to the live stream tonight, I'd like to thank you guys all for tuning in to Fabian Electrical Services. And again, what we're going through is breaker sizing according to the Canadian Electrical Code. We're also We're also going to be opening up the OESC 2024 and look at the rule according to the Ontario Electrical Code. So these are some of the stuff that we're going to follow. And then again, also, like I said, in Canada, we follow these rules simply for it's a law that we have to follow rules and apply them to our daily jobs. So that's basically why you see I have the Ontario Electrical Code book out. It's not a guessing game that we use. We actually have to follow the rules accordingly. And I'm going to run another video here for about 8 minutes.
So hello again and welcome back to Fabian Electrical Services. I'd like to thank you guys all for tuning into today's video. So let's dive right into it. What I'm doing today is going to be an installation. It's going to be the installation of the 400 amp disconnect. The disconnect is mounted already, and what I use for the installation is simply bolts. I made sure I secured the 2x4 on the back end to give it the extra secure to the wall, firm and nice. I don't want the electrical installation to come off the wall in any type or sort. Again, the cable, the electrical conduit that I'm using is going to be the AC conductor. We call it tech cable, and there are parallel runs that's being run from the outdoor meter base. Again, what I like to do with installation like this is I like to make sure that I keep that white sheeting that's there on before I like to keep it on once I land my conductors inside of the panel. I'm going to remove that white sheeting. I also make sure to put my ground bushing on first. This installation is going to come with the ground bushing connection. Reason being is the ground wire has to be grounded off to the actual ground clamp. Ground connection has to be grounded off. I have to make sure that, as you can see in the on the left hand side, you're going to see the other installation. You're going to see my wire is grounded off onto the ground bushing. It is in code compliance. It is a code rule that states that. It is inside of the electrical code book where you would find it. You just have to search. And again, if for all those who are pretty interested in the video, all the apprentices out there, all the journeymans, all the master electricians, DIY guys, homeowners, if you ever need to find out a code rule and you simply cannot find it, you can simply leave a comment in the comment section, and I would guide you through the process. So again, the installation reason that the disconnect is here and not the 400 amp panel is because of the code rule that states anything that's within 5 feet of the electrical panel of the meter base shall have a installation of the panel right away. But when it comes to any installation, electrical installation that's more than 5 feet away from the actual electrical disconnect that's located outside of the home, it has to have a means of disconnect. So the main electrical 400 amp panel is located inside of the electrical room, inside of the basement of the home, and it's more than 40 feet away from the meter base. So the reason is I have to install my disconnect per code, pull my to stay within my electrical code compliance. So as you can see, the reason why I stated that I like to keep the white paper on is it simply helps with the cable. As you can see, the cable is locked in place. Once you disassemble that, it gives you a lot more problems to get the cable inside of the connector. So again, that's why I always make sure I land my cables inside of the disconnect, inside of the connectors, and I make sure that I remove that. Then what I go ahead and do is I simply ground off my ground. I do my groundings. So this is a grounding and bonding installation. There are two different things when it comes to bonding and grounding. Serve two different applications. So never get that confused. Also, you're going to see I have my phasing tape on my cable. Reason is this cable does not come with identify neutral, and in the code book it simply states that your incoming neutral has to be identified. There is a rule where you electrical code rule, code compliance, that states that a particular size of cable we must identify up to. So this is what I am doing here, identifying my conductors with the white tape that is being used. It's always best to have also your line and loads coming in to be separated. Never have them touching each other. It is a code compliance rule that states that your feed that's coming in, your main feed, is not supposed to come in contact with your actual load side that's going out. So for this reason, you're going to see the installation. I'm also going to be using my flat screwdrivers, Robbie screwdriver. Most of the time in this installation, I use my bigger screwdrivers to get the full torquing. Again, also what I like to use is my Milwaukee drills. Very handy, never fails me, gets the job done on a daily basis. Also, set of Allen keys is what is required. A lot of times I use my regular Allen key sets for installation like this. When it comes to the outdoor meter base, I often use another Allen key. It's more of a bigger Allen key that I have. Hopefully I can get to show you guys that on one of my videos. It comes in handy, gets the job done, helps with the risk a lot when it comes to the installation. So again, also this is a part of my videos. There are other videos that I have out there that are has the full installation when it comes to landing my wires. It does have the full installation. You just have to check through my videos to find the other part of this installation. There are many other parts to it, about 3 or 4 other videos that's there. And again, I would like to thank you guys all for tuning into Fabian Electrical. And again, don't forget to like up the video. You can also subscribe to the channel, or you can also become a member, and I will catch you guys on the next installation from Fabian Electrical.
So again, this is about grounding and bounding, and I'm going to pull up the rule for grounding and bounding. So we're going to go back into the actual stream that I have going here, and we're going to look up a rule on the grounding and bounding. I believe that is in section circuit loading and demand factor. So this here is another important rule that we use here when it comes to the circuit load and demand factor. Um, so again, what this simply means, I'm going to read it read a little bit on it here, and so again, I'd like to thank you guys all for tuning in to today's live stream. As you guys come in, don't forget to like up the live stream. Circuit loading and demand factor. You have section 8 here. This section applies to maximum circuit loading, calculated loads for consumer service feeders and branch circuits, use of demand factors, branch circuit positions required for dwelling units, and heater receptacles for vehicles. It also goes on to tell you in this section the following definitions shall apply: the load of lighting and receptacle circuits based on the outside dimension of a specific area of building occupancy as listed in table 14. Calculated load, the load calculated in accordance with the applicable requirements of this section. Also, it goes on to say demonstrated load, historically maximum demand watts information recorded over the at least 24 months period for the same type of facility as the one in question, equated to watts per meter square. We're just actually going to so again, the voltage drop, I would have dropped a rule on the voltage drop, and you see it's going to send you to see appendix B and D. The voltage drop is an insulation in an installation shall be based on the connected load of the feeder or branch circuit if shown. Otherwise, it shall be based on 80% of the rating of the overload or current device protecting the branch circuit or feeder, and not exceed 3% in the feeder or branch circuit, and 5% from the supply side of the consumer service, or equivalent to the point of utilization. Notwithstanding sub-rule 1, where overcurrent devices are selected in accordance with other section of this code, the voltage drop shall be based on the calculated demand load of the feeder or branch circuit. Notwithstanding sub-rule 1, wiring for general use branch circuits rated at not more than 120 volts or 20 amps in the dwelling unit, with the insulated conductor length measured from the supply side of the consumer service to the furthest point of utilization in accordance with the values in table 68 shall be acceptable. Notwithstanding sub-rule 1, at industrial establishment where conditions of maintenance and supervision ensure use of qualified person, the design shall ensure that the voltage at the point of utilization is within the rating or voltage tolerance of the connected device. So I'm going to go to the next page here. The ampere rating of consumer service feeder or branch circuit shall be the ampere rating of the overcurrent device protecting the circuit or the ampacity of the conductor, whichever is less. The calculated load in the circuit shall not exceed the ampere rating of the circuit. Ampere simply means your main power coming in. The calculated load in a load consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that in normal operation it will not persist for a total of more than 1 hour in any 2 hour period if the load does not exceed 225 amps, or B, a total of more than 3 hours in any 6 hour period if the load exceeds 225 amps. A load of cyclic or intermittent intermittent nature shall be classified as continuous unless it meets the requirements of Subrule 3. When a fuse switch or circuit breaker is marked for continuous operation at 100% of the ampere rating or its overcurrent device, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker, and except as required by item B, shall not exceed 100% of the allowable ampacity of conductors selected in accordance with section 4, or shall not exceed 85% of the allowable ampacity of a single conductor selected in accordance with section 4. Where a fuse switch or circuit breaker is marked for continuous operation at 80% of the ampere rating or its overcurrent device, the continuous load as determined from the calculated load shall not exceed the continuous operation marking on the fuse switch or circuit breaker, and except as required by item B, shall not exceed 80% of the allowable ampacity of conductors selected in accordance with section 4, or shall not exceed 70% of the allowable ampacity of single conductors selected in accordance with section 4. The continuous load as determined from the calculated load connected to a cable bus shall not exceed the value specified in subrule 5 or 6. Use of demand factor in any case other than a service calculated in accordance with Rule 8-200 and 8-202, where the design of an installation is based on the requirements in excess of those given in this section. The service and feeder capacity shall be increased accordingly. Where 2 or more loads are insulated so that only one can be used at any one time, the one providing the greatest demand shall be used in determining the calculated demand. Where interlocks are installed to prevent simultaneously operation of electric space heating and air conditioning loads, whichever is the greater load shall be used in calculating the demand. Where a feeder supplies load of a cyclic or similar nature such that the maximum connected load will not be supplied at the same time, the ampacity of the feeder conductors shall be permitted to be based on the maximum load that may be connected at any one time. So again, this is the when it comes to your load calculations here. I'm going to come out of this. It tells you, also gives you a little bit of reading on the calculator for service and feeders. A basic load of 5,000 watts for the first 90 meters square of living areas. Tells you to go to the rule. Plus an additional 1,000 watts for each 90 meters square or portion thereof in excess of 90 meters square, plus any electric space heating loads provided for with demand factors as permitted in section 62, plus any air conditioner loads with a demand factor of 100% subject to Rule 8-106, plus any electrical range load provided for as follows: 600 watts for a single range plus 40% of any amount by which the rating of the range exceeds 12 kilowatts. Plus any electric tankless water heaters or electric water heaters for steamers, swimming pools, hot tubs, or spas with a demand factor of 100%. Plus, except as permitted by Subrule 8-10611, any electrical vehicle supply equipment loads with a demand factor of 100%, plus any loads provided for that have a rating in excess of 1,500 watts, in addition to those outlined in item 25% of the rating of each load if an electric range has been provided for, or 100% of combined load up to 6,000 watts, plus 25% of the combined load that exceeds 6,000 watts if an electric range has not been provided for. And these are all the load calculations here that they have. So I just want to hop over to the actual bonding. As you can see, there's a school calculation, there's a hospital calculation also, and it has the branch circuit supplying electric ranges. So here we go. This is the grounding and bounding. Um, so again, grounding and bounding. This is section 10. Grounding as follows: solidly grounded systems, independent impedance grounded systems, and ungrounded system. Bounding and e- equipotential bounding tells you to see Appendix B. The overall objective for grounding and bounding is to minimize the likelihood and severity of electric shock. So you have it there. That's what grounding and bounding means, is to avoid the shock by establishing equal potential equal potentiality between exposed non-current carrying conductor surface and nearby surfaces of the earth, and to prevent damage to property during a fall as follows. The objective of solidly grounding an electric system and bonding its associated equipment is to establish a low impedance connection between the grounded conductor and the non-carrying conductor parts of the system to stabilize system voltage. And that's what I will be doing at the job where I'm working with the pool. The objective of grounding an electrical system through an impedance is to limit the magnitude of ground fault currents, minimize the damage to equipment resulting from a single ground fault, and stabilize system voltage. The objective of an underground system is to limit the magnitude of ground fault current resulting from a single ground fault and minimize the damage to equipment on the occurrence of a single ground fault. The objective of bonding is to interconnect the non-current carrying conductor parts of the electrical equipment and the system grounded point where one exists with sufficient low impedance to facilitate the operation of protective devices. Sorry, I'm just having issues seeing the actual full word. And establish equal potentiality, and the objective of equal potential bonding is to establish equal potentiality. It tells you to go into Appendix B. So I'm going to and here's another rule here. Current over grounding conductors, there shall be no objectional passage of current over a grounding conductor. Grounding electrodes shall consist of manufactured grounded electrodes, field assembly grounding electrodes, or in situ grounding electrodes forming part of existing infrastructure. Manufactured grounding electrodes shall, in the case of a rod grounding electrode, consist of two rod electrodes, spaced not less than 3 meters apart, interconnected with a grounding conductor, size as prescribed for grounded conductors and driven to the full length of the rod. In the case of a chemical charged rod electrode, be installed to the full length of the rod, or in the case of a plate electrode, be in direct contact with exterior soil at not less than 600 meters below millimeters below grade level, or encased within the bottom 50 millimeters of a concrete foundation footing in direct contact with the earth at not less than 60 millimeters below finished grade. Spacing and interconnected of grounding electrodes. Where there are multiple grounding electrodes at the building, they shall be separated by at least 2 meters from each other. So I'm going to run another video here. Again, I would like to thank you guys all for tuning in to Fabian Electrical Services Inc. And what we're doing here is simply going over the breaker sizing according to the Canadian Electrical Code, load calculations for a residential panel. Um, I'm going to see if I get into the sub-panel wiring in Canada. Also, I'm going to see if I can go through the neutral and ground separation in the sub panel. I believe I would have went through how to size breakers based on ampicity, and we are going to be getting this out of the. We're going to also try to get into the OESC 2024 rule update, a little bit of electrical panel code compliance. However, I don't know if I'm going to get through all of this tonight, so I'm going to have to continue this. So I'm going to run my video here.
Hello and welcome to my YouTube channel, Fabian Electrical Services Inc. Just want to say thank you for everyone who keeps watching my videos and subscribing and liking it. Please don't forget to like, share, and subscribe to my channel. So what I'm basically doing today is So hello again and welcome back to the channel. I'd like to thank you guys for checking into Fabian Electrical Services Inc. Again, in today's installation, we're going to jump right into it. What I'm going to be doing in the installation is I'm going to be installing my electrical boxes for my electrical conduits. These conduits are going to be for my generator feed, generator backup that's going to be installed inside of the home. And what a generator backup does is it simply, once your power has been lost, it's going to kick right in and it's going to shoot your power back on. Again, you're going to also need, along with the generator, you're going to also require the main generator itself that's going to be located on the outdoor of the home, all staying within the code compliance with the installation. So this is simply a box. The reason for the electrical box is I cannot use my Corline, it's called my electrical conduit that I have. It's basically Corline, and I cannot use that on the outdoor, so I have to transition everything over. And the tools that I'm going to be using to do this job is a pair of 10 snips. I'm going to be using my file to file down the holes once the hole is cut. Normally we will use a hole saw to make the hole, but for some reason I didn't have the hole saw, so I had to use my 10 snips in order to get the hole cut. This box again is going to be for the installation of the electrical generator that's going to be located on the outdoor beside of the main electrical meter base for the home. So with this installation, it comes also with the cables that you have to pull. You also have to have your low voltage wiring for the electrical installation when it comes to the generators. Always staying in compliance with your electrical code rules. It's very important to make sure that you understand where to find these rules and apply them to the job when it's necessary. Again, for the installation, I'm not sure the type of cable that I'm going to be installing as yet. As the main service, it is a 400 amp incoming feed, and again, all the whole home is probably not going to be it's probably not going to need to have the backup generator running just for the certain circuits that you need. It's all up to the individual if they want to have the whole entire home on the backup generator. Again, this service is inside of the basement of the home, inside of the room where it's going to be is going to have it's going to have some sort of covering at the end of the installation, so when you walk into the basement, you're not going to see the installation straight. It's going to be hidden. Obviously, it has to be accessible by the code, staying in code compliance. Has to be accessible. All junction boxes, all electrical boxes, octagon boxes, wherever you make a joint, make a connection of your electrical wires, has to be accessible once the work is finished. It also has to have a cover plate placed on the face of the box. You also have to use your morettes when it comes to making your joints secure and firm. You also require the proper connectors to be used, proper couplings, whatever it may be, for the application, for the electrical installation. You have to make sure that you have all proper material on the job site when the installation is being performed. It's best to always double check your electrical code book to make sure that you stay within your code compliance rules. You can obviously go above and beyond once it doesn't interfere with your budget on the job site. Very important to always keep that in mind. Also, it's very important to make sure that you calculate what size wire you're going to be using for the installation, what electrical boxes are going to be used, what electrical conduit are going to be used, whether it be liquid type, PVC conduit, the whole even NMDW. It's always best to make sure that you figure out what type of wire, size of wire, breaker size you're going to be installing before you obviously start the electrical installation. And again, this is the 2-inch conduit, electrical PVC, Corline. It's called. The trade name we normally use is Corline. So this is a 2-inch pipe, and the other pipe that's above is a 3/4. So that pipe is going to be for the high voltage line that's going to be going to the actual generator transfer switch. So now that you have seen the electrical conduit, this is the electrical conduit that I mentioned that cannot be used on the outdoor. So for this reason, I'm going to be installing the electrical box. It is a 8x8 box, I believe, 8x8 electrical box that I'm using. And again, this box is going to be simply placed for a matter of connections. instead of using the conduit that's not required to be used on the outdoor by code rules, staying within the code compliance. We also have to remember that the code book overrules the installation, and it's best to have the proper installation before it's inspected. Once the inspector arrives on the job, you don't want to have a defect on the job. So it's always best to make sure that your electrical installation stay within the code compliance rules. And once you find yourself staying within your code compliance rules, you're not going to have any issues with the inspector at all. A lot of my work, a lot of my electrical installations, a lot of them I either know my rules by heart, or I somehow have to search them. And it's best to take the time out to do your research before you even book for an inspection. Once the inspector arrives on the job, if for some reason there is a defect, the electrical installation has to be up to par with the code compliance rules. So you're going to have to somehow fix the electrical installation before you can have it passed. So like I said, it's always best to make sure while you're doing your installation, double check your code book, make sure everything is good to go. So again, I would like to thank you guys all for tuning in to Fabian Electrical Services, and all my fans who've followed me throughout this time. I'd like to thank you guys all for tuning in, and please, for all those who hasn't subscribed to the channel, go ahead and subscribe to the channel. Make sure you become a member. Stay up to date for more content that I'm about to drop, and I will catch you guys on the next video.
So again, hello and welcome back to the channel, and I'd like to thank you guys all for tuning in to today's live stream. Again, as you guys come in, don't forget to like up the live stream, and what we're attempting to go through is I don't have a lot more time here, maybe another 20 minutes or so. So we've already been through a little bit of load calculation for residential panels, residential homes, sub panel wiring in Canada. We haven't spoke about that, so I'm going to tick off what I've spoke about tonight here. Neutral and ground separation, no. So load calculations, we did that, and breaker sizing according to Electrical Canadian, to the Canadian electrical code. Electrical panel code compliance will have to be another time, and so on. So I'm going to continue to read this grounding conductor here. So 10-114, grounding conductor size, except as permitted by sub-rule 2, the grounding conductor shall be size not smaller than number 6 wire if of copper, or number 4 if of aluminum. Again, when it comes to copper, is the best for your grounding, also for your bonding. I think it's only copper that you can use for the bonding. The grounding conductor shall be permitted to be size smaller than prescribed in set sub-rule 1, provided that it is not smaller than the current carrying conductor of the system being grounded. Installation of grounding conductors, see Appendix B. The grounding conductor shall be electrically continuous throughout its length. When necessary, devices to control the effects of stray earth current shall be permitted to be connected in series with the grounding conductor. A grounding conductor shall be protected from damage mechanically or by location, where stray or sleeve constructed of magnet materials used to be enclosed. Grounding conductors shall be connected to the grounding conductor at both ends. A grounded conductor installed in the same raceway with service conductors shall be insulated except that an I can't see that. Uninsulated grounded conductor shall be permitted where the length of the raceway does not exceed 15 meters between pull points and does not contain more than the equivalent of 290 bends between pull points. Grounded conductors connection to grounding electrodes. It tells you to see Appendix B. The grounded conductors shall be connected to the grounding electrodes at a point that will assure a permanent ground of means of a bolted clamp, copper welding by a fusion welding process, bracing, silver solder, or other equally substantial means where practical Where practicable, the connection to a grounding electrode shall be accessible. That's DC. That's as you can see the rules here for when it comes to the DC. DC systems required to be solidly grounded. DC systems shall be solidly grounded unless they meet the requirements for underground systems or impedance ground system. Conductors of a DC system to be grounded. The conductor of a DC system to be grounded shall be one conductor of a two-wire system or the common conductor of a three-wire system. Grounding connections for DC systems. DC systems that are to be solidly grounded shall have the grounding connection made at a single point as close as practical to the supply source. AC systems required to be solidly grounded. AC systems exceeding extra low voltage shall be solidly grounded if, by doing so, the maximized voltage to ground does not exceed 150 volts or the system incorporates a neutral conductor. AC systems exceeding the value prescribed by Sub-Rule 1 shall be permitted to be underground or impedance grounded, provided that they meet the requirements for ungrounded systems or impedance ground system. Extra low voltage AC systems shall be solidly grounded where run overhead outside, supplied by transformers energized from systems of more than 150 volts to ground, or supplied by transformers energized from ungrounded system. Conductors of an AC system to be grounded. The conductors of an AC system to be grounded shall be one conductor of a single-phase two-wire system, the identified conductor, the mid-phase conductor of a single-phase three-wire system, the identified neutral conductor, the mid-phase conductor of a multi-phase system having one wire common to all phases, the identified neutral conductor, one conductor of a multi-phase system having one phase grounded, the identified conductor, and the mid-phase conductor of one phase of a multi-phase system. The identified conductor for the multi-phase system referred to in Sub-Rule 1. Only one phase shall be permitted to be grounded. So I'm going to, like I said, head over to another section here. Again, this is dealing with a whole different here we have this again for those who are tuned into the live stream. I'd like to welcome you to Fabian Electrical Services Inc. 10-500 current over bonding conductors. See Appendix B. There shall be no objectable passage of current over a bonding conductor. Clean surface where a non-conductive protective coating such as paint or enable its use on conductive equipment, conduit couplings or fittings. Such coating shall be removed from the threads and other contact surfaces are penetrated to ensure a good electrical connection at the point of bonding. Rather dissimilar metals that are not compatible cannot be avoided at bonding connections. Connections shall be made using metals of material that will minimize deterioration from galvanized action. Continuing of bonding conductors. No automatic cut-offs switch shall be installed in the bonding conductor of a wiring system unless the opening at the cutout of the switch disconnect all sources of energy. Equipment bonding. Bonding for the fixed electrical equipment except as permitted by Subrule 2, non-current carrying conductive parts of electrical equipment shall be connected to a bonding conductor. Non-current carrying conductive parts of extra low voltage electrical equipment shall not be required to be connected to a bonding conductor. Conductors in parallel runs. Where conductors are installed in parallel separate cables, raceways, or bus, a bonding conductor shall be installed with each group of parallel conductors. Bonding continuity for equipment, for service equipment. The bonding continuity for service raceways, cables, armor cable, sheets, and all services equipment enclosure containing service conductors, including meter fittings, boxes, or the like, shall be assured by threaded couplings and threaded connections to the conductive enclosure, with joints made uptight where rigid metal conduit is used. Then it tells you Rule 10-606, bonding continuity are other than service equipment. Bonding continuity of metal raceways, sheeted cable, or armored cable shall be assured by one of the methods specified in Rule Okay, so sorry about that. Bonding continuity of metal raceways. Metal sheeted cable or armored cable shall be assured by one of the methods specified in Rule 10-604 or by using standard box connectors made up tight. Two lock nuts, one inside and one outside of boxes and cabinets, or one lock nut and a metal conduit bushing, provided that the bushing can be installed so that it is mechanically secure and makes positively contact with the inside surface of the box or cabinet. Reducing washers shall not be used to maintain the bonding continuity of the wiring system. Where metal raceway service serves as the bonding conductor and expansion joint and telescoping section are installed, the electrical continuity of the raceway shall be assured with a bonding conductor. Bonding means fixed equipment. The bonding means for fixed equipment shall consist of one of the following: an effective metallic interconnection between field equipment consisting of metal raceways, metal sheet, or cable armored except armored as specified in Subrule 2-3, the sheet of minimal insulated cable when not of copper or aluminum as specified in Subrule 4. So again, I'm going to leave that there. Um, let's see how. Okay, so we're going on to almost 2 hours on the live stream. So again, what we would have covered, some breaker sizing according to the Canadian Electrical Code, load calculation for residential panel. We would have went through sub-panel wiring in Canada. No, we didn't do that. Electrical panel code compliance, I didn't get into that topic. So again, for all those who has missed the live stream, you can catch the replay right after the live stream. You can also there's a link pinned in the comment section to my other videos, my other previous live stream. And again, I'd like to thank Up Movement TV for checking into the live stream, and also East Badness. And again, thanks for joining tonight's live stream on breaker sizing, loading calculations, and sub-panel wiring. So we covered a lot from code book rules to real-world install tips, all focus on staying safe and compliance with the OESC 2024. If you miss anything, the replay will be available right away. Be sure to check out my other live streams on grounding, bounding, panel work, and disconnects. Links are in the description. Until next time, stay code compliance and stay safe.